Okay, so we have a net force problem, and so first off, free body diagram. Always a good first step in any kind of force problem. And so we have this sleigh, and we'll just draw it kind of similar to what we had in that diagram there, or just draw it as a box if you wish. We have the horse pulling in this direction, the force of the horse, and then we have a friction force that's opposing it, always opposing the motion, friction force there. All right, so our free body diagram, we're not really talking about the weight or normal force or anything at that point. So we're just looking at those two horizontal forces. So we can say the net force is equal to, and first of all, let's make sure we know which way we're considering positive. Quite often we make positive just to the right or up or something like that, but in this case, the sleigh is being pulled to the left, so that might be a good reason to make it positive to the left. Now, if you made it positive to the right, no sweat. It'll still come out to be right, just as long as you stay consistent with that. So for us, positive to the left is fine. So the F net just means all of our forces being added. And so the force of the horse, 2,000 newtons. And we considered left to be positive, and the horse is pulling left, so that being a positive, perfect. The force of friction, that'll oppose the motion, so that'll be to the right, just like we showed in our free body diagram. And to the right means that that would have to be a negative. Okay, and so we can add those up, one to the left, one to the right, so we end up with 1,000 newtons. And we stop and consider that, and we see it as a positive, and we look back. It's always good to define what your positive is, just so you're clear on what your answer means. And positive is to the left, and we came up with a positive, so we say that our net force is to the left. And look at a free body diagram. The horse is pulling with more force than the friction, and so the net force to the left, yeah, that makes total sense.